Oh, hi, everybody. Welcome back. And I hope you all had a wonderful Easter holiday. And also, I hope that your exam number 3 went well. And now we'll continue our chapter 10. So today in this lecture video, we're going to talk about section 10.2. So we're going to focus on the quadratic functions for these sections here. So in these quadratic functions, we have two topics we want to cover. So the first one is here, we're going to just take a look in general, what is the quadratic functions, basic definitions, and the few properties about the quadratic function. So we want to take a look at the graphing, and so what do we call this vertex, and what is the axis of symmetrics, how to find x-intercept, y-intercept. Then after that, in the topic number 2, we're going to introduce like the function transformations. So we're going to use some technique we call the translation and refraction to graph the functions here, okay? And in order to break this section down, I don't want the video is too long, so overwhelm you. So probably we're going to break the section 10.2 to 2 lecture videos. Okay, so we're going to have a basic, the video number 1, we're going to talk about just focus on the quadratic function, the basic properties, those things. Then on the video number 2, we're going to talk about the translation and how to graph the function. So I think that this way, you'll be able to break into smaller pieces. Maybe it's easier for you to to watch the videos here. Okay, so let's take a look. What is the, the first things here, let's take a look. What is the definitions about the quadratic, right? Okay, so yeah, let's take a look at the definitions here. So the definition about a quadratic function, this is one of the functions is so popular, and we use it almost in all different kind of the science disciplines area of the science here. So the way we write the quadratic function, you can write it like f of x, or you can say it's the y equal to. So that means the way we code is quadratic, so it's always has x squared and plus bx plus c here, okay? And so in here, those are the constants. So A, B, and C here. So we said A, B, and C, those are what? Those are the real numbers. And A cannot be equal to 0. The reason why we want to specifically say A cannot be equal to 0, that means the quadratic functions here, they have to have what? The square terms here. So if A become to 0, and then it will become what? It will become a linear functions, right? So that's why we say that A cannot be equal to 0 here. So the first thing is here, we're going to take a look at the graph of the quadratic function. The graphs here, the graph of the quadratic function, the graph, the graph is called, we call it a parabola. Okay, so the graph we call it a parabola. A lot in the real life situations, and the curve will look like a parabola. So for example, if you throw things up in the skies, right? So if you throw a piece of rock up in the sky, so when the rock reach the top, then going to fall down, right? So the curves here, so for examples here, right? So you're throwing a rock up to the sky, right? Right, so the rock, you're going to go up and then finally reach the highest point and then go down. Right, so this curve is here. This is what we call this parabola curves here, right? So like as you can see, so this is what we call this parabola curves here. And so it's just like, like the other situation, like when you shoot when you shoot a gun or fire a missile, it's the same way, right? So it's like they go up and then go down here, right? So this kind of the shape, right? We call what is here, we call this a parabolas here, okay? Okay, so now let's take a look, because this is a parabolas here. So let's go to the next pages here. So we say our function is ax squared plus bx plus c, right? So we know it's parabola. So the graphs here, okay? So is this parabolas here will go up or go down? That means this parabola sometimes will go like this, and sometimes it will go like this, okay? So how do you decide which way to go? And so this is the one where, in here, if your A, so for the graph first here, this is A is less than 0. So when the A, as soon as you see a quadratic function, if A is less than 0, then you immediately know this this parabola will open downward. And for here, you will see this is A greater than 0. So you will see immediately, maybe you don't know the exact locations, but then you will see immediately, this graph will go open up and down. So for examples here, right? So let's take a look at the example. So if you say y is equal to the 2x squared minus 3x plus 1, all right? So for these ones here, you say, oh, here, this is the coefficients, right, in front of my x squared. So I know immediately this function, when I graph it, so should go opening up here, right? So the same way here, like if you have so it's like a negative 4x squared plus 5x minus 1. Okay, so for example, if you see these ones here, then you immediately see, oh, this is the coefficient in front of x squared. So what's that means tell you? That means when you graph it, and this will be a function going open down, right? So that's the first thing. So when you try to see the graph, you know this is the graph you're going to open upward and downward here, okay? Okay, now let's take a look here. And then the next things here we want to talk. So this is the graphing part, right? So let's go back to the first page. So we finished here, the graphing open down or open up, right? So the next things here we're going to talk about is vertex here, right? So the vertex. So what is a vertex? Those are the point, those are the turning point, right? So those are the turning point. Those are, we call this vertex. So where is it going to turn here, right? So the vertex here, the formula you might want to remember. So the vertex here is going to turn at the x values here will be the negative b over 2a. Then the y value will just be you plug into here negative b over 2a to see what is the y values here, right? Okay, so let's take a look. Okay, so let's take a look at our examples here. Let's see if we can find the vertex or not, right? So like in here, the first example, we say y is equal to the 2x squared minus 3x plus 1, right? So the first things here, let's try to identify my what? My ABCs, right? So this is A, this is, remember, including the whole things here. This is B, this is C. So this is A, this is B, and then this is C, right? So I know A is equal to 2, B is equal to negative 3, and the C is equal to 1 here, right? Okay, so now, you just say, okay, so the vertex here, right? According to this formula, so my x value will be what? Negative b over 2a. So you will see here, the negative b will be negative 3. So be careful, see here. 2a is 2 times 2, so it's what? So my vertex here will be 3 over 4. Okay, so the x is equal to 3 over 4. So what is the y value? Then the y value will just be you plug the 3 over 4 to your function. So this is my functions, right? So it's 3 over 4 to the square minus 3 times the what? 3 over 4 plus 1. So let's take a look, right? So it's 3 over 4, the square times 2 minus. Okay, so you will get a y is equal to negative 0.125. Okay, so what's that mean? That means in here, right? That means this vertex here. So what is this vertex? This vertex is at 3/4 and negative 1.125 is equal to negative 1 over 8. So you will be able to, so that means negative 1 over 8. That means this is where I'm going to terms here, right? So it's pretty straightforward, right? So let's take a look at my other examples here. We just put in here. So let's do it one more time. Then I think you should get a pretty good idea. So this is y equal to the negative 4x squared plus 5x minus 1 here, right? So the first thing is identify A, B, C. So this is A, this is B. Be careful, it's everything, right? Don't forget that the signs here. So A is negative 4, B is equal to 5, C is equal to negative 1, right? So now I substitute the vertex formula, x equal to negative b over 2a. So negative b is negative 5, 2 times negative 4, right? 2a. So it's negative 5 over negative 8. So it's 5 over 8, right? So that's my x values here. Okay, now you substitute back to whatever your functions, right? So it's negative 4. Now your x is 5, 8. So 5, 8 squared plus 5 times 5, 8 minus 1, see here, right? So let's take a look at 5 over 8. 5 over 8 square times negative 4, right? Okay, and then plus 5 times 5 over 8. Okay, and then minus 1. Okay, I got a 9 over 16. Okay, so I hope that my calculation is correct. So this is 9/16. So what's that mean? That means for this functions here, this is the what we call this vertex, right? So that means this vertex is at the 5/8 and what is 9/16 here. That's what we call this vertex, all right? So very important, right? So make sure, this is why you put it into the formulas here. So let's see here. Then we talk about the vertexes here. So it's okay. So so the next things here we call this axis of symmetric. Axis of symmetric is really pretty easy because after you find the vertex, the axis of symmetric, that means where is this graph symmetric, right? So let's take a look here. So let's see here. So this is where we call this axis of symmetric. So it's the line passing right through the vertex. Oh my, this is a terrible graph. Okay, so I hope this one's here. So this one's is like da 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 da. Yeah. And so this is a great here. So this blue line is right at the center of this parabola, right? So when you fold the both sides, they will match. So that's why we call this axis of symmetrics. So let's take a look at this examples here. So remember the axis of symmetric is the one we passing through the center point here. So this is the axis of symmetrics, right? So what is the axis of symmetrics here? So for this graph, the axis of symmetry is just the x values, right? So this is easy. So it's x equal to the 3/4. That's what we call this axis of the symmetrics here. All right. And so the same way here, right? So now you can do the axis of symmetrics is for this graph here is just the line passing through, right? Okay, so this is the line passing through the axis here. So what is the axis of symmetrics here? Axis of symmetric is 3/4. All right, so let's we go back to here. We talk about the axis of symmetrics. Then the x-intercept and the y-intercept, right? We did this in the linear function. So it's the same things here. So like in here, the x-intercept is what? You set what? You set y equal to 0. Then you need to use factoring to find the x value, right? And then what is y-intercept? Y-intercept is here is what? You set, this one's easy. You set x equal to 0, then find the y values here. All right. So let's go back to here. And so in here I say, okay, I want to find the x-intercept and the y-intercept here, right? Okay, so let's do the y-intercept for this function. So y-intercept is a lot easier, right? Now we're going to find a different example to do x-intercept. We can factor easily. Okay, so now y-intercept is when the, well, so y-intercept is when x equal to 0, right? So you put the x equal to 0s here. So what is y-intercept? Y equal to what? Y equal to 1s, right? Because you put the x back to here is 1. Okay, so that's why the way you write it, the y-intercept is 0, 1. So for here is the same thing for the y-intercept here. So it's when the x equal to 0, So what is y-intercept when x equal to 0? -1. So that's how do you write it? -1 here, right? That's what we call this, the y-intercept here. So the x-intercept, right? So x-intercept, basically, you know, you will need to try to factor that. I'm going to use a different, easier example to show you that. Okay, so let's go to the next pages here. Okay, so let's try to take a look at these examples here, and then let's go over the whole thing so we just did. Okay, so this one's here, y is equal to the x squared plus 5x plus 5x plus 6. Okay. Okay, so this is a 5x plus 6, right? So the first thing here, we need to identify the ABC. So this is x squared. So that means the coefficient in front is 1, right? So we will say that A is equal to 1 and B is equal to 5 and C is equal to 6, right? So now we can do all our things here. So the vertex here, let's try to do one more time. Vertex is kind of important. So x equal to the negative b over 2a. So negative b is negative 5 over 2. So it's negative 2.5. Then you substitute here to get the y. So it's negative 2.5 square plus 5 times negative 2.5 plus 6, right? So this will give you negative 1/4. So you know, because this is a positive, right? So you know your graph going to open upward, right? So your graph going to open upward. And then, well, let me later do, let me do this graph later, right? Okay, so now we have the, so this is a vertex, right? So the vertex is negative 2.5 and the negative 1/4. All right, so then I know the axis of symmetrics. The axis of symmetrics is just the x values, right? So it's x equal to negative 2.5. Hi, a while ago, if you heard some dog whining, that was my dog. And every time when I try to record a lecture, she must feel bored. So she keep whining and want to go outside. So that's a while ago, I need to pause for a few seconds, you know, let her go outside to the backyard and running around, you know, so it's kind of interesting. She must know I'm recording and the message sounds boring. So that's why you said, let's go play. See? But anyway, so here, okay, so we find the axis of the symmetric. So it's x equal to the negative 2.5, all right? Okay, so the next thing is here, I want to find the y-intercept. So the y-intercept is x equal to 0. That means y will be equal to 6. So the y-intercept is 0, 6. Now, the x-intercept, after you find this, you will know how easy to graph it. So x-intercept is y equal to 0. That means x squared plus 5x plus 6 equal to 0 here, right? So that means, okay, so in order to find it, let's do the factoring. We need to use a factor to solve it. So x squared plus 5x plus 6 is x plus 2 times x plus 3 equal to 0, right? So if you times both equal to 0, that means the first one equal to 0 and the second one equal to 0, right? So that means x plus 2 equal to 0. That means I will get the x equal to the -2, or x plus 3 equal to 0. I will get the x equal to the -3. So I will have a 2x intercept. So the way you write it is -2, 0, and this one is -3 zeros here. Okay, so let me show you why those things are helpful to graph here. Okay, so here, okay, so 1, 2, 3, 4, right? Okay, so the first things here, let's try, okay, the vertex, right? So I know the vertex is -2.5 and -1/4. So -2.5 and -1/4. So this will be my vertex, right? And okay, so also then they say the vertex is the same thing as the axis of symmetrics, right? And because also because of the a greater than zeros, right? So a greater than 0, so I know my graph going to open what? My graph going to open upward here. All right. Okay, so now in here, the next things here we want to see is the y-intercept, right? So the y-intercept here, okay, so the, see here, okay, so y-intercept, and so in here, you know, the y-intercept here, okay, oh, why they erase all that? Okay, I don't want to clear all the drawing. Okay, so here. Okay, so the here I go here. I guess hold on. I think this one is I make the scale too big. When I make the scale too big, I cannot draw very well. So okay, let's redraw that. Okay, so here. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so let's do it again. The vertex here is -2.5 and 1/4. So it's here. Then the axis of symmetrics here is like and this is axis of symmetrics. And I know it's open upward. Okay, so now I'm going to find what my y-intercept, right? Y-intercept is 0 and 6. So it's 1, 2, 3, 4, 5, 6. All right. And now my x-intercept here. So my x-intercept here, it will be -2 and 0. So -2 and 0 is here, and the -3 and 0 is here. Okay. Now after this, I will be able to draw my graphs here, right? So here, because you go like a of course, it means it's not. It should be curved, right? So going to pass the 6 here. And so how is the other line go, right? So this is a 3, right? So it's going to pass the 6. So I know this is like so it's like a 2. So it's so the here it's going to go like this way, right? So it's a sorry about my curves. It's not very curving, but it is a parabola. So that's why you will see it. That's how your graph looks like here. All right. And so one last thing here, I want to talk about for here, the graphing here. So for examples here, Okay, so if I have a functions f of x or y is equal to 2x squared minus 4x plus 5. Okay, so let's write out the ABC. So this is A, this is B, this is C, right? So A is equal to 2, B equal to the negative 4, C equal to 5. And now let's see, in the, like first thing, so I want to find the x-intercept, right? So let's just take a look at the x-intercept. So the x-intercept is y equal to 0, right? So use 2x squared minus 4x plus 5 equal to 0. As you can see, I cannot factor this one, right? It's not easy to factor. So I say, okay, I use in the quadratic function. Okay, so I'm going to use the quadratic function, quadratic formula. Right, so that means x could be, right? So x is equal to, like what, 2a negative b plus minus square roots of the b squared minus 4ac here. So I can use a quadratic formula to find where is the intercept, even I can hard time. So this is difficult to factor, right? So this is difficult to factor. So I use the quadratic formula. So let's see what happens here. 2a, so it's 2 times 2, so it's 4. Negative b, so it's negative 4, plus or minus b squared, so it's negative 4 squared, minus 4ac, 4 times a times c. Okay, so let's see what happens here. So this is a C, this is a 4, this is a plus minus. So negative 4 squared is what? Is 16. And the minus 4 times 2 is 8. 8 times 5 is 40, right? Uh-oh, what did you find here? You find here, this is less than zeros here. That means I cannot have anything is less than 0. So what that means here? So that means that I cannot take the square roots, right? So that means that I don't have. So that means no x-intercept here. Because my square roots, inside the square roots is less than 0. My quadratic formula tell me that. So now, what is my graph going to look like? So the graph will be something, of course, let's see, I don't know where is the exactly, so the graph probably is like somewhere in here, right? So because the A is, is the positive, so that means my open up. So that means my graph going to do like this. It will not touch the x-axis, right? So that's why there's no what? No x-intercept. And we do have a y-intercept here is 5, right? So here's a 5. So we do have a y-intercept. So that's what it means. If you have something, it's very difficult to factors, right? And so then you can use the quadratic formula and to see where the x-intercept. So like for this problem, because inside the quadratic formula, the square roots, I get a negative number. So that's why I know there's no x-intercept. That means that my graph is open upward above the x-axis here. All right, so that's good. So this is a good place to stop. So we will stop here. Then for the section 10.2, we still have the second topic. It's like how do I use the transformations and the reflection to graph it. And we will break it down. And so we will put a part 2 about the section 10.2. So you won't have like the hours video to watch. So I think 11 probably is better for you, okay? So, okay, so guess I'll talk to you next time and have fun watching these videos, okay? Bye.